Okay, you guys, today we're going to be talking about populations and samples, and this again is part of our data, statistics, and probability. So, have you ever heard of the president approval ratings that they do on the news? And they say, let's say 53% of the population approves of how the president is running the country. Well, do they really call 53% of all the Americans in the United States? The answer would be no. Okay? So what they're talking about is that the whole population would be the whole population of the United States. And they would just take a small group of those to sample. Okay? So let's look at the example that they give us. Okay? It says, we're going to survey the number of books read by 7th graders in Richmond. And the population is the whole group that is being studied. So it's all of the 7th graders in Richmond. Okay? The sample is just part of the population. So in our example, it might be 7th graders at one middle school, Jefferson Middle School. We could use this in Kokomo. You know, they could look at all 7th graders in Kokomo and just survey those that are from Northwestern. Okay, here's the thing. A random sample is a sample in which each member of the population has a random chance of being chosen. So, these are the good ways to have a random sample. You have a computer select every 10th name from an alphabetical list of each 7th grader in Richmond. And like you guys know, at school here we have random drug testing. They can't just say, oh, I'm going to select this person because I know they're going to be good. Everybody's name is put into a computer, and the school doesn't even do this. It's from an outside company, and it spins out random names. So everything has to be randomly selected. Okay, so then we have what's called a biased sample. That is a sample that does not truly represent the population. So if I said, I stood outside a Justin Bieber concert and asked them who their favorite singer was, you think that's going to be biased? I would think so, because if I'm outside the Biebs concert, everybody coming out is going to say that they like the Biebs. Okay? If I stood inside a library and asked every 10th person if they like to read books, that would be a biased sample because they are at the library. So in our case, a biased sample would be the 7th graders in Richmond who are taking honors English. Well, you're only looking at one group of kids. You have to look at everyone. So it says, tell if each sample is unbiased or biased. An airline survey passengers from a flight that is on time to determine if the passengers on all flights are satisfied. Well, I'm going to have to say that this would be biased. Why do you think that is? Well, because they're talking to the people that came in on a flight that's on time. If they talk to those people whose flights got canceled or were 2 and 3 hours behind, they would probably not be satisfied. Okay? Number 2, it says, newspaper randomly chooses 100 names from its subscriber database and then surveys those subscribers to find if they read the restaurant reviews. I would have to say that this is not biased or unbiased, simply because they took 100 names randomly from their database of customers. Next one says the manager of the bookstore sends a survey to 150 customers who were randomly selected from a customer list. Okay, look at the key words. They were randomly selected, and they chose 150 from their whole customer list. I would say that would be not biased. Okay. And it says a team of researchers surveys 200 people at a multiplex movie theater to find out how much money state residents spend on entertainment. Well, let's think about that one. They're looking at 200 people, great. But look where they're at. They're a multiplex movie theater asking them how they spend money on entertainment. Well, if you're at a multiplex movie theater, aren't you watching a movie or doing something fun there? So I would say this is definitely biased. All right, this next one says, choose a letter of the sampling method that will better represent the whole population. So Clinton School Cafeteria, student satisfaction. Mark surveys 40 students who are in his classes. 72% are satisfied with the food in the cafeteria. Or Tammy surveys 65 students by randomly choosing names from a list of all students in the school. 85% are satisfied with the school cafeteria. I would have to say the best one would be B, okay? Because Mark's only looking at 40 students who are in his class. That's everybody in his class. That's not getting a sample from everybody outside and in other classes. All right, predicted winner in the election for mayor. Harris telephones 100 randomly chosen voters. 54% plan to vote for Mayor Green. Julia asks 70 people whom she knows. 45% plan to vote for Mayor Green. I would not go with Julia because obviously she doesn't like Mayor Green because 45% of her people she knows aren't voting for him. So you definitely go with Harris because it's randomly chosen. All right. Tell if it's biased or unbiased. A town official surveys 50 people in the library to decide if the town residents want a library expanded. Definitely biased. They are at the library, right? And those people are going to want it expanded. For a cable company, a cable TV company randomly calls 200 customers and asks if they are satisfied with their service. Randomly calls 200. That's the key. It is not biased or unbiased. George surveys 15 students on the soccer team to learn whether middle school students want more money spent on school sports. This is definitely biased, and I would have to say because he's only asking middle school students who are on the soccer team, and that's not a very big sample of the whole population. All right, a factory produces 1,200 computers per week. The manager of the factory claims that fewer than 50 defective computers are produced each week. In a random sample of 500 computers, 2 were defective. Tell if the manager's claim is likely true. Okay, we're going to set up a proportion on this one, and we have to be consistent. In their sample, they sampled a total of 500, so we're going to put total on the bottom. That's total, and then 2 were defective. So we have defective over total has to equal defective over total. Well, it says here that there are 1,200 computers per week, so that's the total. So we're going to find out how many were defective. And when you do all your cross products, you get 500x equals 24,000 divided by 500, and you get 48. So there are going to be 48 defective computers. The manager claims that there are fewer than 50. Is she right? Yep. I want you to do this one on a sheet of paper. Number 1 worksheet, due Thursday. Okay?